Riprendiamo la sessione pomeridiana del JTF. Prima di dare inizio alle relazioni del pomeriggio, volevamo però invitare i relatori al tavolo per la sessione domande relative alle relazioni presentate questa mattina. Quindi invito Chris Corti, Jim Binnion, Beatrice Biagi e Stefania Trenti ad accomodarsi sul tavolo per le eventuali domande da parte del pubblico. Prego.
I've got a question from Andrea Friso. Apart from process control, are there any ways for a small company to make inspections on their grain structure without access to a metallography laboratory? I think there are ways you can probably get an indication by the way material handles when you process it and things, but there is no easy way. At the end of the day, you have to do some sort of metallography. If you don't have the facilities in-house, then maybe you have to go to an external laboratory to get that sort of information. But normally you'd only be worrying about it if you've got a problem in production or you've got some pieces returned from a customer that is broken or deformed or the stone has fallen out or something, and then probably that would justify you going to a bit of expense to try and understand, is there something about the material, is it not the right hardness, or is the microstructure wrong or something? If you've got a piece that's broken, then you can look at the fracture surface where it's broken. It might be the shank that's broken on a ring or the claw on a stone setting. Just looking at the fracture surface can probably tell you something about the structure and the type of fracture, whether it's an intergranular or a transgranular fracture or something like that, and that can give you a clue. But yeah, at the end of the day, if you want to understand the microstructure, you need some way of sectioning it and looking at it. I've got another question that's just been handed to me. How did people find the right grain size in the past? Well, I'm probably old enough to be part of the past. I think in the old days, they didn't know. They didn't really understand about these things. It was just trial and error. This works. If we do it this way, we have a problem. And they have half a story, not a full story of what the problem is about. Second part of the question, is it true that vintage jewellery was having better metal quality, stronger, etc.? No, I think vintage, if you look at vintage jewellery, it's like if you look at old cars or old aeroplanes or bridges or something, they were over-engineered. The Victorians over-engineered everything because they didn't have an understanding and a way of optimising their material so they could work it closer to the limit. No, they certainly didn't, because until we had the advent of science, metallurgy coming on board really, probably in the 1950s, we really didn't understand structures. We guessed at what was going on, but we didn't really understand until we had, the science there to point us in the right direction. When and who proposed to find better grain structures? I don't think it was ever when or who. I think it's just like most things. These things evolve. We get a better understanding. If you look at additive manufacturing technology, that was a technology developed in other industries, and we in the jewellery industry said, that looks interesting, let's see if we can use it to suit what we want to do. You can talk about laser welding technology and laser cutting technology and engraving technology developed in other industries. They see benefits. We say, can we see some sort of benefit for our industry? And then you adapt the technologies and make the machine smaller or whatever you need to do to suit the industry. So no one really sort of said, this is what we need to do. I think it's just as our knowledge and understanding grew, that we tacked onto that and said, yeah, we can use this information to our advantage in our industry. And the last part of the question, do companies, jewellery repairers, jewellery makers have experts and generally control of alloys they receive? Yes and no is the answer to that. Big companies tend to have people that are technically trained. Alloy manufacturers, for example, are good examples. I know a lot of alloy manufacturers, and I'm sure Ligor and the other Italian manufacturers here will say that they get a lot of inquiries from their customers, and some of them can be major customers, that the material doesn't appear to be performing properly. They've got a problem in manufacturing, or the customers are complaining, and they rely on the expertise that's with the alloy manufacturers because they have the facilities and the understanding. So some big companies do. Some big companies have, proper laboratory facilities and testing facilities. Others have very rudimentary facilities and rely on their suppliers to give them their technical support. So it depends. I always say to people when they ask me, who should I buy an alloy from, who should I buy a machine from, I say, go to those companies that have got the technical knowledge and expertise. So if you have a problem, they can help you. If they haven't got it, they're not going to be able to help you, and you're not going to get the answers you need. I think certainly most alloy manufacturers would say that a lot of their complaints, the customer is blaming your material isn't the same as it used to be, and very often that turns out not to be true. I mean, occasionally there are mistakes, but it's people are using things differently, or they're not treating the material with the respect that it needs to give you the performance that you want from it. So, there's no black and white answer there. It is a whole spectrum of things. So that's all the questions I've got. So I can hand over to Jim.
So I have a question from Andrea Friso. Did you experience any damage on resins after applying vacuum, such as uncured liquid being pulled out? I have had that experience, and it relates to how the patterns are cleaned before starting the vacuum. I'm sorry. I have had a problem with it if I used isopropyl alcohol to clean the patterns, as the resin manufacturers recommend using isopropyl alcohol. I found that I get much better results if I use a water-based cleaner to clean the patterns after growing them. So I use hot water and a detergent, a laboratory detergent called Alkanox, that's basically just a high-grade detergent to clean the patterns before I put them in the vacuum chamber. I found that the use of a solvent led to sometimes some strange problems. I had a couple of patterns that grew bubbles on the surface during the vacuum treatment, and I had quite a few patterns that would crack during the processing when I used the isopropyl alcohol. And by switching to a water-based detergent rather than isopropyl alcohol to remove the excess resin after printing, all of those problems disappeared. I think what happens is that the solvent is getting into the areas of the pattern that are not completely solid, and it's mixing with the resin, and you're getting a very thinned resin that can grow these bubbles. And it also definitely leads to the cracking when you heat it up. And I think it's due to excess shrinkage, again, caused by introducing a solvent into the semi-cured resin. And that's the only question I have.